Good morning, students. Welcome back to science class on the chapter gravitation. In the previous class, we had discussed thrust and pressure. Okay, so in this class, we will discuss buoyancy and Archimedes principle. Okay. See here, for example, the heavy objects like a ship and some other boats, okay, they'll all float in the water. Okay, suppose take a needle, just keep it in uh, just put it in a water. What will happen? A small needle, it will sink. But what about ship? It will float. Correct? Okay, so instead of that if you can take one paper, so put it in the water, so even that paper is also, it will float. Okay, yes, so do you know the reason why? Yes, that is secondary, we will discuss later. Just imagine, we have discussed the thrust and pressure, etc. Correct? Why the knife edge are very sharp, and why camels can walk easily on the deserts. So now, suppose I will keep some objects in the water. For example, you have a see here one bucket. Okay, so just water is filled here. Okay, suppose now I will keep an object here. What will happen? If you keep one object here, what will happen? So now, do you think that this object, it will experience any kind of force? Correct. See, when you keep the objects here, what will happen at that time? So if the object is little heavier, then the water level raises. Correct. The water level raises. Okay. So why? Because here some people occupy space here. Okay. So see here, if you keep the objects in water, if you place any objects in the water, then it will experience some kind of force. Okay, so when you keep the objects in the fluid, what will happen? So those objects, they will experience some kind of force. Okay, just imagine, take a empty water bottle. Okay, just close it. If you see, just imagine if you have kept that water in this here in this bowl. Okay, this is a bottle, water bottle. Okay, it's an empty. See, when you press this one, what will see? You will feel some kind of resistance, right? You will feel someone is pushing from this side. Okay, see, when you apply force here, so then you can feel some kind of force. Correct? Okay, so when you keep the objects in the fluids, whether it is water, milk, or diesel, petrol, whatever, when you keep the objects in the fluids, then those objects, they will experience they'll experience an upward force. They'll experience an upward force. So that upward force, okay, is called buoyancy force. Okay. For example, while swimming, you will feel lightweight, right? So yeah, if you know swim, you can swim. Otherwise, you will sink. Okay, so there also we see while swimming, there also we will apply what we will experience some kind of force. Okay, so here when you keep the objects in the fluids, they will experience some kind of force. So that upward force is called buoyancy force. Okay. See, the upward force exerted by the water to the bottle is known as upthrust or buoyant. Sorry, we call it as buoyant force. So while pressing, if you apply force here, what will happen? You can feel some kind of resistance. Resistance means what? Some kind of force. That force is against your against your force, because you are applying force in this direction, and you will experience another force in this direction. Okay. Clear? So here, this upward force, okay, this upward force is called buoyant force. Okay. Next, do one more experiment. For example, take one. See here, initially, so just take one stone, okay, tie it to the spring. So just this is a spring, okay. So now this is the length. Now keep this stone and this spring here, like this, okay. So now see here. Now, is there any changes in the length of this spring here? Just imagine, say this is say 12 centimeter. 12 centimeter. When you keep this spring and stone in the ball, okay, at that time, do you think that the length of the here the length of the spring is same? You know, here it extends. That spring it extends. Why? Because here we have tied one stone. But when you keep that stone and this string in the water, at that time, do you think that is there any changes in the length of that string? Yes, definitely. Its length changes. Okay, its length reduces. Why? Because so when you keep that stone in the water, what will happen? So normally we have discussed it, right? So all the objects they will experience an upward force. Okay, so now this object it will see here, it will experience an upward force. Okay, so that's why what will happen? The length of this string reduces. Okay, so this upward force, the force from the fluids, the force from the water. Okay, here this force from this water. Okay, so that force is called buoyant force. Okay, you know, all object experiences force buoyancy when they are immersed in a fluid. The magnitude of this buoyant force depend on the density of the fluid. You know, for example, just if this is a water, okay, then just take milk. Okay, so now here, say here also, because see here also the length of the spring changes. Why? Because we kept in a milk. Milk is also, it's a liquid, right? But here the, see here, just imagine here its length is reduced to say 11 centimeter. So here also we can't say in the milk. Here also see length of this spring is reduced to 11 centimeter. Maybe it is 10 centimeter. Maybe it is 8 centimeter, like that. Okay, so that depends on the density of the fluids. Density of the fluids. We discussed that what is density. You know, the density of water is different. The density of milk is different. The density of water is different. Then density of milk is different. Okay. So when you keep the objects in the fluid, so all the objects they will experience some kind of upward force. So that upward force is called buoyant force. Clear? Next. Now, why objects float or sink in water placed on the surface of the water? Okay, so this is very important. You know that ship take one small needle. Okay, when you put it in the water, what will happen? It will sink. Okay, so why it will sink? So here we can say that the density of this that nail, okay, or pin. That pin is made up of iron, right? So density of that nail is greater than the density of the water. So that's why it will sink. So clear? So if you suppose if you take one rubber, when you keep rubber, that it will float. So then we can say that the density of that rubber is less than the density of the water. So that's why it will float. And this pin, it will sink. Why? Because the density of that pin is less than the density of water. Then what do you mean by density? Okay, see, density means it is a mass per unit volume. Okay, so density means mass per, density is equals to mass per volume. Okay, now just imagine, see, density means mass per volume. Okay, see, just we have one cube. Okay, see, now this is 1 meter cube. Okay, all the sides are equal to 1 meter. And take one more. Okay, so here also the lengths, all the sides are equal to 1 meter. Now I will give you first. I will give you iron. Okay, so just I will tell you, put it in this box. We can make that into piece. Okay, so first you will fill this box. Okay, equally. Okay, and here I will give you put water here. First you will put iron here. Okay, and here water. Clear? So now later I will tell you, just measure both. Check the weight of the sorry. I will tell you, check the mass of the this cube and this one. This is and this is B. Okay. So here this cube is filled with iron and this is filled with water. So I will ask, measure. So which one which cube will have more mass? So definitely we can say that this iron, it has more mass. Why? Because here this cube, in this cube we can add more atoms or molecules of iron. Clear? But here we can add less number of atoms or molecules. Why? Because here it is a see, it is iron. The arrangement of particles in iron and arrangement of particles in water, that is different. Iron is a solid, right? Here particles are tightly arranged. But what about here in the water? The particles are loosely arranged. Okay, suppose if you take silver here, Si, okay, if you take silver here, what will happen? If you take silver here, so here also you can add, but the difference is there, right? So maybe here you can add more number of atoms than iron. Okay, so in this box you can add more number of atoms than this iron. Okay, so at that time we can say that silver, the density of silver is greater than the density of iron. Okay, so earlier we have discussed water, right? So here we can add less number of atoms compared to iron. So here we can say that so the density of iron is greater than the density of water. Okay, suppose if you take diesel also. Okay, so I will tell you first I will put diesel here and here water. Okay, so both are liquid, but the arrangement of particles in diesel and water, that is different. So here we can say that so in this cube, so more number of particles of water we can add here. Here less number of here less number of atoms. Okay, so here we can say that the density of water is greater than the density of diesel. Okay, so clear at density means so mass per volume. So in a given volume, how much you can add, how much quantity or how many atoms you can add. So that gives the density of the substances. Okay, so clear, right? So density. Now see here, why objects will float and sink. This is pin. Okay, so here it will definitely, we can say that it will sink. Why? Because so this pin is made of the density of a pin is greater than the density of water, so that's why it will sink. And it take rubber, what will happen? So here this rubber, the density of the rubber is less than the density of water, so that's why it will float. Okay, clear. Now tell me, you know, it is a pin, it is in a gram, right? Just imagine, what about the ships which weighs tons, okay, which carries in there we have used lot of what iron contents, okay, but it will float. Okay, so here that is one density reason, but here this ship is made up of iron, right? So that it should sink, right? But it will float. Why? Because here, you know, we have discussed, right? Weight means what? So one is a density, or we can say that here the weight means what? It is a downward force. Okay, weight means what? We have discussed, we have studied, right, in the previous classes. Okay, weight means that is downward force. Okay, for example, you are standing on surface. What is that? Yeah, you say weight is 100 Newton. So what is the meaning? That 100 Newton, that is the force of attraction, or how much force you are supplying on the earth. Okay, next. See here, you know, when you keep the objects in the fluid, what will happen? They will experience an upward force. Okay, here the weight of this pin is greater than the weight of this spin is greater than the upward force. Weight means what? Force only. Okay, that downward force from this spin is greater than the upward force or buoyant force. Upward force or buoyant force. So then it will sink. Okay. Now what about the rubber case here? This will also the force, the weight of this rubber or that downward force of that rubber is less than the buoyant force or upward force. So then it will sink. So here also the same reason. Why? Because here here this pin, it will cover less amount of area. But what about ship? It covers huge area, right? In water, it covers huge surface. It covers huge surface. Okay, so that's why the weight from that ship or the downward force from that ship or the downward force of that ship is less than the upward force or buoyant force. Upward force or buoyant force. So then that this ship it will float. So clear, right? Why objects will float and sink? Okay. Suppose you have an object. If it is a sink, if it is sinks in water, what is the meaning? So which means the downward force of that object is less than the upward force. Then it will sink. Okay. Then it will sink. If the weight or that downward force of that object is less than the upward force, then it will float. Okay, so here if you take this pin and this ship, here this ship it covers more area, more surface area. So that's why it's a downward force. It's a downward force reduces. But here this pin it covers very less area, right? So that's why it's a downward force. It's a downward force. Downward force increases. Okay. So here I'll repeat once again. When objects float and sink, if the downward force of the objects or weight of an object is greater than the upthrust force, we can call it as here. We can call one is buoyant force, upward force, or upthrust force. Okay. But better we can use here buoyant force. Okay, say listen carefully. When the weight of an object or downward force of that object is greater than the buoyant force, is greater than the buoyant force, is greater than the buoyant force, at that time that object it will is greater than the buoyant force. At that time that object it will sink. Okay, if that downward force or that weight of an object is less than the buoyant force, then it will float. Okay. Okay. So suppose now see here. Now this is ship. Okay. Now this ship make it to the water in just like a ball. Okay. Now convert the shape of this hollow shape. Right. All the ships are in hollow shape. Okay. Usually. So now make this hollow shape into one circle. At that time it will cover less area. Right. So at that time it will sink. Why? Because it's a downward force. It's a downward force is greater than the upward force or buoyant force. So then it will sink. Okay. Yes, sir. Next move to Archimedes principle. Okay. Archimedes principle. Hope you all know that word called eureka. Okay. So that word is because of him only. I think that story. If you don't know, just search it in YouTube. Okay. So why that word eureka is famous? Next, so listen here. We have discussed what when you keep the objects in water, what when you keep the objects in fluid, what will experience? They will experience a buoyant force or an upward force. So now I want to calculate that upward force. I want to calculate that. I want to calculate that upward force. How to calculate that upward force? Okay, so I want to calculate that upward force. How to calculate? Okay, see, if it is mass, we can calculate easily. But how to calculate this one? See, for that is difficult, right? When you keep the object here, what will happen? It's the water level rises. See here, just when this is the initial level. Okay, so now here I keep one object. What will happen? At that time, the water level rises. See, up to here. Up to here. Now I want to calculate this upward force. So how to calculate that upward force? Okay, see here. Now when you keep the object in the fluid, at that time the water level increases. Correct? So now you have to take this raised water level. You have to take this water because this is, see here, water level raised, right? You have to take this one. Okay, so collect it in a beaker, a separate beaker. Collect it in a separate beaker. Correct? So then measure in a physical balance. Then measure in a physical balance. So you will get the weight of this water, right? So you will get the weight of this water. Weight means what? It is also force. Okay. So now this upward force or this buoyant force is equal to the weight of this water. So what is this water? This water is displaced water, right? This is the raised water. When you keep the object here. Okay, when you keep the object in the fluid, at that time that water level rises. So you have to collect that water level. Okay, so here you have to take this water with respect to the initial position. This is the initial. So water level rises from here to here. So you have to collect this water level in the beaker. Okay, so then you should measure that in physical balance. Okay, so you will get the weight. So weight means what? It is a force. So this force is equal to this buoyant or upward force. Clear? Okay, so using this method we can measure the buoyant force. Okay, so now what is the statement? So now we can define this statement in we can state Archimedes principle. So here, when a body is immersed fully or partially in a fluid, okay, when a body is immersed or when an object is immersed in a fluid fully or partially, okay. See, sometimes some objects they will partially sink and partially float like this. Like this. Clear? Okay. So when a body is immersed fully or partially in a fluid, it experiences an upward force. Correct? It will experience an upward force. Okay? It will experience an upward force. So that force is equal to the weight of the fluid displaced by it. Okay, that force is equal to the weight of the fluid that is displaced by it. Means when you keep the object here, okay, so when due to see, when you keep the object here, what will happen? Its water level rises. This water level rises. Why that water level changed? Because you have kept the object in this ball. Okay, so that water level raised because of here we kept the object here. Okay, so this upward force is equal to the weight of the fluid displaced by it. Displaced by means that displaced by this object. Okay, see, in a simple words, when you will keep the object here, water level increases. Just up to here. So here you have to take this water. Okay, you have to measure this raised water level. Okay, this weight is equal to the, what if you measure here, what you get here, this weight is equal to the upward force. Okay. So this is the Archimedes principle. Yes, next move to relative density. Next move to relative density. Yes, sir. You know that word already, you know, right? What is it? Density. Density means it is a mass by volume. Okay. So then, what do you mean by relative density? See here, we are comparing density of other substances. Density of other substances with respect to density of water. Okay. So the density of water is 1000 kg per meter cube. Okay. 1000 kg per meter cube. Clear? So this is the density of water. Density of water, that is 1000 kg per meter cube. Now, so here we should compare the density of other substances with respect to density of water. For example, you know, if you want to know the density, first, what is the essence of density? Here, density is equals to mass by volume. Mass by volume. So we measure mass in kg and volume in meter. That is meter cube. The essence of volume is meter cube. So that's why the essence of density is kg meter cube. Kg meter cube. Okay. Next. See here. So now relative density means, for example, to calculate relative density, we have formula relative density is equal to density of the substance. Density of substance divided by the density of water. The density of a substance, okay? The density of a substance divided by density of water. Water means here I want to calculate the, for example, say density of silver. I need a relative density of silver. I need the relative density of silver. If you want to calculate relative density, here you have to substitute the density of a silver divided by density of water. Okay. Now, just imagine. Take one small example. Say, the density of silver is density of silver is density of silver. Density of silver is 10,800. Sorry, 10,000. Yes, 10,800 kg meter cube. Okay. So now I'll tell you calculate the relative density of silver. So substitute here density of silver. What is that? Density of silver is 10,800 divided by density of water. That is, then density of water is equal to 1000 kg per meter cube. So now I am calculating relative density of silver. Okay, 0 cancel. So you will get 10.8. Okay. So what is the meaning? Here you got the relative density of silver is 10.8, which means the density of silver is 10.8 times greater than the density of water. Got it? The density of silver, that is 10.8 times greater than the density of water. Clear? See here the relative density means here just we are comparing densities of other substances with respect to water density. How many times what the density of other substances greater than the density of water or less than the density of water. Suppose for example, say just roughly take, okay, just imagine, say relative density of iron is 7. The relative density of iron is 7. So what is the meaning? Here we can say that the density of iron, see here, the relative density of iron is 7. Okay, it is 7. What is the meaning? So here meaning is the density of, only density of iron, not relative density. Here the question is, here they have given relative density of iron is 7, which means density of iron is 7 times greater than the density of water. Clear? Now, what is the extent of relative density? So, the relative density, it has no unit. It has no unit. Why? Because, see, to calculate formula, relative density, to calculate relative density, we have formula, relative density of substance is equal to density of substance, density of a substance divided by density of water. So here we have to substitute the density of the substances. So the assent is kg per meter cube only, kg per meter cube. If you substitute here also the density is kg meter cube. So kg meter cube cancel. Okay, so that's why relative density, it has no unit. Okay. So here relative density means here just we will compare the densities of other substances with respect to water. How many times it is greater than the water density of water, or how many times it is less than the density of water. Okay. Yes, successfully we have completed this chapter. In the next class we will discuss some problems. Okay. Thank you.